Welcome everyone to Learning with Rev. In this video, we are going to be visualizing what batch normalization layers do in Keras. So to start off, we are going to be in the Keras documentation, looking at the definition of batch normalization. It applies a transformation that maintains the mean output close to 0 and the output standard deviation close to 1. Now, what does this mean and why is that important? So we're going to switch back to our Excel document here. And we see we start off with the number 7. We're applying a 3x3 convolution and another 3x3 convolution. After that, if we look at these values, they range from anywhere from 0 all the way up to 22, and that is not very normalized in any way. I calculated the standard deviation and the mean. Standard deviation is 5.2 and the mean is 4.1. And when we're dealing with data in a neural network, we really want our data always to be normalized, whether that's between 0 and 1. Also, another common normalization is from -1 to +1. In our case, we are going to be normalizing to 0 and trying to get a standard deviation close to 1. So this will be similar to a Gaussian distribution. The values aren't the same as Gaussian, but it's centered over 0. So for every point in this next picture, we take the value initially, subtract the mean from it, and divide by the standard deviation. As you can see here, our image has become a lot cleaner, less blurry, and our numbers now go up to 3, and they probably go to -3. If we look at our average is 1.1 times 10 to the -16th, so very close to 0, and our standard deviation is 1.001. So if I scroll down, this here is the same as this. It's just so we can see them next to each other. I'm going to close this just so we can see both at the same time. And we are going to do one more convolution over it. So we're going to convolve both of these, this one and this one, with this 3x3 convolution. This is the one that has been normalized. This one has not been normalized. The unnormalized one has values that are insanely large, 94 right there, 88, 86. And I bet if we look at the standard deviation of this right here, it's going to be massive. I'm guessing in like the 40s, 24, very large. But if we look at this one here that has been normalized once already, if we calculate that out real quick, it should be much lower. I'm guessing, 4.5, much lower. And then after this convolution, you might do another normalization between your convolutions. There is debate whether you should do the normalization before or after max pooling. Based on your architecture, it might be better in one place or another. Maybe have a convolutional block with a bunch of pooling layers, and then you do your normalization. But this normalization is great because this feature extraction is much richer. So these two images here are the same size. This one's a lot blurrier. We only have a border of low values here. But in this here, we have a border of 1 and sometimes not even 1. In this right here, we keep that really thick border. And the rest of the features from the 7 have kind of been reduced down some because we've normalized the data. So I hope this was a good explanation of batch normalization and how normalizing your data does help out with the training process. If you have any questions, please leave them in the comments below. If you like this video, please like it and share it. And I hope you learned something, and I'll see you next time.